Hello there, welcome to another quick maths tutorial. Today I'll be doing a video on discrete random variables. So this is a topic which comes up in both regular but also further statistics. So I'm going to count this for both. Bearing in mind, I will discuss some of the content is not applicable, not relevant to just regular statistics. So if you do not do further, not everything in this video is relevant to you, but some is. And if you do further, you will obviously be taking the regular statistics as well, and therefore all the content will also be relevant. So I just want to talk about the difference between continuous and discrete variables, because this is purely about discrete variables. And to understand what they are, it's best to understand what they're not as well, which is continuous. So first off, a continuous variable, if we look on the diagram on the left, let's say x is a continuous variable. It can be any number imaginable between a given range. And by range, I just mean you give a lower bound, upper bound for what it could be. So I don't know, x is between 1 and 2. Now there's an infinite number of numbers between 1 and 2. If you decide to count decimals, fractions, anything like that, you could pick any recurring decimal. You can add like the smallest nudge to it, and all of those could be a possible value for x. Root 2 is a value that's irrational. You can't even get a fraction for that, but also 1.999 recurring. Whereas discrete variables, on the other hand, they're not necessarily. A good example is coming in integer amounts only. So like up here, you can see I've got 3 orange blocks above the discrete variable part, and so it seems as if there can only be a whole number of blocks. It comes in integer amounts. That's a good example of a discrete random variable, but it's not the only type. You could also have like fractions. So if something comes in half amounts, like I don't know, wavelengths on a standing string, something like that. Only they can come in half wavelengths, but you can't get quarters and things like that. They just don't form. So the idea is between a range of values, it can only take on a certain amount. It's quantized. Because certain values just don't make sense in a given range for that variable to take. So we're looking at like the probability of certain events happening, and they will be discrete. It can only be set certain things. It can't be that. I'll show you in a minute. Actually, look at a probability distribution. So we have what's called a discrete random variable x. The big X is what I mean. And it's defined as it can take on 5 values here. So this you might have a spinner, which has 5 faces, and when you spin it, one of the 5 faces comes up. Little x is all the range of possible values that big X can take. So it'd be 1 to 5, which is discrete because obviously it's not everything between 1 to 5. So this is what's known as a rectangular or better uniform distribution. It's a special type. As all the values of x that big X can take have equal probabilities, evenly distributed. There is no bias to either of the faces. We have a nice unbiased spinner here. So you've come across this type of distribution before, known as the binomial distribution. That is also a discrete distribution, as n could be any whole number from 0 up to n. So distributions are, with binomials, the probabilities aren't evenly distributed. Some values of x have higher probabilities than others. So that might always be the case. But it is the case that the probabilities must always add up to 1. Because that's sort of saying what's the probability that at least one of the events happens. And of course, one of them has to happen. So their total probability must be 1 always. That's why I've got the equivalent to symbol there, because that is true for all values of x. The mean, or sometimes called in special and further, expected value, can also be calculated, and it is the most likely value that x will take. It generally isn't one of x though, because it's like what's the mean of these weights of fish I've got. It's probably not going to be one of the weights of the fish, but it best represents the whole group of the fish. So this is like what is the most likely thing I'll roll. So it may be a decimal, which doesn't make sense, but in this case, it's not. In this example, it's worked out to be 3. Bear in mind, the formula for the expectation is just for further statistics. Give that here. for you to use. So you multiply each value of little x by its probability. It's like a weighted mean, a weighted sum. So it is a mean in a sense. And also, purely for, I think we're facing here, the only word missing here is values. Just want to point that out. Sorry for that. The variance of x can also be worked out, which represents how close on average the values are of x are to the expected value. So that's sort of like the average distance from the mean that all the data are. Now, this might sound familiar to standard deviation, something you've looked at in regular statistics. Variance, of course, is a square of standard deviation, or standard deviation is the square root of variance. Variance can be calculated in further statistics as the expectation of all the values of little x squared minus the mean squared, e of x squared. So you might want to work out e of x first in this case. So again, that's for further statistics only, and you must remember that formula. So basically, yeah, you multiply each of the probabilities by the value of little x, so 1 to 5, all squared. And then we subtract, the mean was found to be 3, so we subtract 3 squared. And that just gives us 2. So that's what the variance is in this case. Here I've got one example for you. There will be more practice at the end in the description. And also I'll leave the answers if you scroll even further down in the description for you to have a just check how you're doing with this. I'll go through one quite a long question, you generally are for these, just so you get all the skills necessary in one go gone through. Given that the variance of x is 3 lots of the expectation of x, and the probability of getting a 2 is twice the probability of getting a 3, find the probability that x is less than or equal to 1. So that's the probability that x is either 0 or 1, because there's only 2 values which that makes sense for. Little note. So what can we do? We have some unknowns here, and that's a problem. We can first off set up an equation with a, b, and c in it. So it's got 3 unknowns. Bear in mind, we're probably going to need 3 equations. We are given 3 separate pieces of information here. Talk about that in a minute. So the first piece of information is not even given in the question, but it's just something that is universally always true, and that is probabilities must add up to 1. So I've just added them up over here and simplified a bit, and we have a plus b plus c is 0.45. The expected score is we can work that as well, still be in terms of a's and b's and c's, and it's a plus 2b plus 3c plus 1.95 when you work that out. So go on to the next one. It's not quite another equation yet, so I say I had 1 in braces for the first equation. The second one I'm forming, I'm going to work out the variance. So let's just work out the variance there. So multiply, again, we're using the formula, we square all values of x, multiply by their corresponding probabilities, and minus the mean squared. Now that's not very nice to actually square out these brackets yet, so I'll leave that for the time being. And we basically combine, set their equals. We multiply the variance by the mean by 3, and we set them equal to each other for another equation, because that is another related a, b, and c. Finally, we don't actually need 3 unknowns, because we're told the probability of getting a 2 is twice that of getting 3. So this should be, b should be double c, b should equal 2c. So we don't actually need any b's in there, we can just have it in terms of a's and c's. So every time I see a b, I'm going to replace it with 2c. 1 becomes this, a plus 3c equals 0.45, and equation 2 becomes this, which is quite a bit nicer. Now we can substitute in 1 into 2 to try and find where they overlap, because there's only two unknowns here and we have 2 equations that solve simultaneously. It's not very nice to just eliminate, so I'll substitute in this, but I've rearranged it to have a equals 0.45 minus 3c. So every time I see an a, I will replace it with that, and there should be no a's left. So yeah, there's no a's anymore now. And finally, what I'd like to do is we substituted the equation in from 1 into 2, and now there's no a's at all left, and we just have a quadratic in terms of c here. This can be solved using your calculator. You do not need to use the formula for this. You won't get any marks for working. So it's just like a one-step thing you can do now at A-level. There, in doing so, you get two values for C. We reject the one bigger than 1 because probabilities cannot be greater than 1. That doesn't make any sense. And using our value for C, we know what A is in terms of C. So here, I'm just going to highlight that in red. This right here is A. Oh, there. They're the same thing as just using my value for C because we know that A is 0.45 minus 3C. Because the probability that x is less than 1 is the probability that it is 0 or 1. There. So it's A plus 0.1. And we get out 0.241 to 3 decimal places as our final solution to that. So yeah, as I said, there'll be more smaller questions in the description for you to have a go at, and their solutions further down for more practice. They won't be as large as this. I hope you enjoyed watching this video, and yes, thanks for watching.